All right, we're on example 3 of section 2.6 rational graphs. And so we're looking at the rational graph x squared minus x minus 6 divided by x squared plus 3x plus 2. Again, the first thing I recommend you do is to factor the numerator and the denominator completely. So let's do that. So x, 3, 2, and then the bottom. All right, so the first thing you notice is that you do have a common factor. That common factor, x plus 2, is going to create a whole. So that is going to change a lot of things that we're going to do. So again, the domain, if you look at how to find the domain, we look at the factors of the denominator. We set each of them equal to 0 and solve for x, and then write it in this format. So that means that x equals -2 and x equals -1. So we write it as x such that x cannot equal -2 and -1. Again, the reason it can't equal that is because that would cause us to be dividing by 0. We have a hole. So if we look over here, it says a hole is a break in the graph. A hole occurs when there are common factors between the numerator and the denominator. To find the x coordinate, you set the common factor to 0 and solve for x. So I will take the common factor, which is x plus 2, set it equal to 0 and solve for x. So I get x equals -2. So we've got a hole, and the x coordinate is -2. To find the y coordinate, substitute the x coordinate into the simplified function. So when I talk about the simplified function, technically I would cancel these factors. So the x plus 2, the common factor, I'm canceling these. And then I'm substituting a -2 for x here and here. So I get -2 minus 3 over -2 plus 1. So I get -5 over -1, which is 5. So the y coordinate is 5. So there's a hole in this graph at -2, 5. And when we draw that hole, we're going to exaggerate it. When you look on the graphing calculator, you're not going to see the hole because there are points at -2.000001, and so that it's going to kind of converge at that point. So you're not going to see a big gap, but we're going to overemphasize that hole. All right, so then we're going to look at our vertical asymptotes. So factors of the denominator that are not factors of the numerator. Well, because we have a hole, we have to look at the factors of the denominator that are not factors of the numerator. Only this one is going to give me a vertical asymptote. So there's going to be a vertical asymptote at x equals -1. Horizontal asymptote. Remember, we're looking at the degree of the numerator versus the degree of the denominator. Degree of numerator is 2, the degree of the denominator is 2. So we do y equals leading coefficient divided by leading coefficient. So y equals 1 divided by 1 is 1. So if there's a horizontal, there is no slant. Again, if the degree of the numerator is less, so let's say, I'm sorry, over here, if the numerator if the degree of the numerator is less, so let's say this has a degree of 1 and this has a degree of 3, you would have y equals 0. None of these examples have an example like that, so where it would have a y equals 0 with the x-axis horizontal asymptote. So I want to talk about, just wanted to mention that. X-intercepts, back to the front. So we have factored our numerator already, and all factors of the numerator that are not factors of the denominator. So we can't look at this factor because it's common with the denominator. So only looking at that factor up there. If I set that equal to 0, x equals 3. That means there's going to be an x-intercept at 3, 0. And then for the y-intercept, you're going to substitute zeros in for all x, and that is going to give you your y-intercept. So if I let all these be 0, so I get -6, and then that would be 2. So -6 over 2 is -3. So that y-intercept is 0, -3. Remember, I'm substituting all my x's with 0. So 0 minus 0 minus 6 would be negative 6. 0 plus 3 times 0 is 0 plus 2. Negative 3. That's where I'm getting this y coordinate. Okay, so I have everything. I'm going to start looking at drawing my asymptotes and the points that I already have, and then going to my graphing calculator and finding other points. So x equals negative 1. Y equals 1. Got the point 3, 0, and 0, negative 3. And remember, we have a hole at negative 2, 1, 2, 3, 4, 5. And so I'm going to make an exaggerated hole right there. So I'm going to go to my calculator. Again, I'm going to put the entire numerator in parentheses. Divided by the entire thing in parentheses. The entire denominator in parentheses. And then hit graph. All right, so let's get some points in this region over here. So where y is less than negative 1. So let's go to our table, the second graph. So some negative x values. So at negative 10, we're at 1.4, so that's about here. At negative 7, 9, 8, 7, we're at 1.6. At negative 5, we're at negative 2. At negative 3, we're at 1, 2, negative 1, 2, 1, 2, 3. I think I screwed up here. This should be negative 5, 2. That's here, not there. And then we have the exaggerated hole at negative 2, 5. Let's like negative 1.5. Negative 1.5, we're at 9. So here we go. So there's that behavior in that region. And then let's look at some values. At 0.5, at negative 0.5, we're at negative 7. 9, 8, 7. We've got our x-intercept is 0, negative 3. At 1, we're at negative 1. So we've got this going on. 3, 0. And then let's do 10. So at 10, we're at 0.6. So here. So we've got this part over there. All right, so our last example. We're going to find the domain. We're going to first factor the numerator and the denominator. The denominator is not going to factor, so we've got x plus 1 here. So x, negative 3 plus 2. First thing I always check, is there going to be a hole? No, because there isn't any common factors in the numerator and the denominator. So my domain, again, if you want to get your characteristics of rational graph cheat sheet, get that out. It comes from the denominator. I set that equal to 0, and I get x equals negative 1. So my domain will be x such that x cannot equal -1. We said there's no whole because there aren't any common factors in the numerator and the denominator, so no whole. Vertical asymptote. So first I look for common factors. I don't have any, so there's nothing I cancel. And then I look at unique factors in the denominator, which is this one, set it equal to 0, and I get x equals -1. So that's my vertical asymptote. Horizontal asymptote. So the degree of the numerator is 2 because I have a power of 2 as my highest power of x in my numerator. My degree of my denominator is 1 because this x is a power of 1. So what happens? The degree of the numerator is greater than the degree of the denominator. That means I have a slant asymptote. So I do not have a horizontal. And then how do I get that slant asymptote? So that's going to be an equation of a line like y equals 2x plus 3 or y equals -x, something like that. So how I get that equation is I actually divide the numerator by the denominator. I can use long division or synthetic. So if I can use synthetic, I can do synthetic. This one I can do synthetic because this is x to the first, and there's no anything other than a 1 here, so I can do synthetic division. So I'm going to divide that. So down here, you set your x plus 1 equal to 0, and you get x equals -1. That goes in your box. And then your coefficients of your numerator, your polynomial, so I have 1, -1, -6. I'm going to drop down my 1 here. -1 times 1 is -1. -1 times plus -1 is -2. -1 times -2 is 2. I add these, I get -4. You don't worry about the remainder. So this is x minus 2. So my asymptote will be y equals x minus 2, my slant asymptote. My x-intercepts come from the factors of the numerator. Again, back up here, x-intercepts, factors of the numerator. All factors of the numerator that are not factors of the denominator. So I don't have any common factors, so I'm going to use both of these factors, set them to 0, and I'll get x equals 3 and x equals -2. So I'll have two x-intercepts, 3, 0, and -2, 0, and my y-intercept. Replace all your x's with 0. So I get -6 divided by 1, so -6. So my y-intercept is the point 0, -6. So let's do our asymptotes. My vertical is at x equals -1. Seems to be a common theme here. Remember, we don't have a horizontal asymptote. I have a slant asymptote. Y equals x minus 2. So my y-intercept is -2. And my slope of this line is 1. So from there, I'm going to go up 1 over 1, up 1 over 1. And I actually have a ruler here. All right. And then I'm going to plot some points that I have. So I have 3, 0, 1, 2, 3, 0, -2, 0, and my y-intercept 0, -6. So that means I'm going to have something in this region, and then I'm going to have something in this region. It can only be in corresponding, like opposite regions. So you could have something here and here, but since you have points on this side, you'll have, and this side you can see that's where those, where the graph will be. So again, we'll get our graphing calculator out, get some other points. So in parentheses, x squared minus x minus 6, parentheses divided by parentheses, x plus 1, graph. So you can kind of see, they don't ever show you your asymptotes. If you have an older calculator, it's going to look like it's showing you asymptotes, but what it's doing is it's connecting the graph to those asymptotes, and weird things will start happening. So just go by the points in your table. That's really important. So let's get some points. Second table. Again, I want to get some values where x is less than -1. Oops. All right, so at -8, I'm at 9.4. So right here. At -5, I'm at -6. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And then I want to look at -1.5. You could do -3, -3. There's a point. And I like to get as close to that asymptote as I can. So -1.5, I'm at 4.5. So I've got this going on that side of the asymptote, vertical and horizontal and slant. And then let's look at some points. -0.5, I'm at -10.5. So that's down here. We've got 0, -6. All right, so at 2, 1, 2, we're at -1, 2, we're at -1 and a third. And then we have 3, 0, 6. 1, 2, 3, 4, 5, 6. Right here. So we kind of got going some points on that side. All right, so that's your fourth graph there. That's it for rational graphs.